Dear student, today topic is about hybridization of organic molecule. What is hybridization? In hybridization process, what happens? Atomic orbitals having equal energy, they mix together. But the detailed discussion of hybridization is in chemical bonding chapter, not in this carbon and its compound. But in this particular topic, we will know how to calculate the hybridization. So, in organic molecule, there are only three types of hybridization and they are sp3, sp2 and sp. You will find only these three types of hybridization and you can find sp3d something like that, but that is in the inorganic molecule, okay, not here, not for the carbon, okay. So, hybridization in organic molecule, there are three types. How to know that for any particular carbon the hybridization is sp3 or sp2 or sp? How to know that? So, learn the techniques and tricks. If you find any carbon is connected with single bond only, then that carbon is sp3 carbon. See, if I write CH4, okay, so if I expand the CH4 structure, it will be in this way, C, H, H, H and H, correct. So, can you see carbon is involved only with single bond. Any carbon who is involving only with single bond, that carbon is considered as sp3 carbon, okay. That is why I said that if any carbon is involved only with single bond, that carbon is sp3, okay. Let us talk about sp2. If any carbon is double bonded one time and single bonded two times, then that type of carbon is also sp2, okay. And if any carbon has positive charge, that time also sp2. See, if I write in this way like CH3, CH double bond CH2, okay. See, you can do directly also. If carbon is double bonded one time, it means sp2. You must remember carbon should be double bonded one time, sp2 over. So, this carbon is what? Double bonded one time, it means this carbon is sp2 carbon, very simple. What about this carbon? It is also sp2. Why? Because it is also double bonded once. So, this carbon is sp2 carbon, very simple, okay. See, this carbon connected only with single bond. How? One single bond, this one, and three hydrogens. So, three hydrogens are like one hydrogen here, second hydrogen here, third hydrogen here. It means this carbon has connectivity with single bond only. So, this particular carbon is sp3 carbon, okay. So, I hope you got the idea about sp3 and sp2. Let us see some more examples. See this one. This is called cyclohexane actually, name no need to remember, just learn the hybridization calculation. So, see this carbon is involved only with single bond, only, no double bond, no triple bond. So, what is the hybridization? sp3. What about this carbon? I told you in the last class that at bending position, that bending position is carbon, okay. Like suppose if I write in this way, so this point of intersection is carbon, this is carbon, 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 carbon. I told you that the initial point is carbon and final point is carbon. I told you if it is like this, then carbon, carbon, and bending position is also a carbon, we revised, okay. So, tell me about this one. Again sp3 because involved with single bond only, that is why. Okay, let us draw the next structure. This one. This structure is known as benzene, organic benzene. Dear students, there are two types of benzene, one is organic and other is inorganic. This is C6H6 and organic benzene. They may ask you that in organic benzene, the carbon atoms are sp2 hybridized, sp3 hybridized, sp hybridized, unpredictable in that way. Okay, so let's calculate with this trick. Very easy it is. Can you see this carbon? Okay, this carbon is double bonded. If any carbon is double bonded once, what it is? sp2. So this carbon is sp2. See, both are two different structure. This is called benzene, this is cyclohexane. Okay, don't think both are same. No, they are not same. Okay, check this carbon. This is double bonded carbon. Yes or no? So this is also sp2. In fact, in benzene molecule, all the carbon atoms, all the 6 carbon atoms are sp2 hybridized. Okay, let's learn something more. So this is sp. How to know that this particular carbon is sp carbon? It's very simple. If any carbon is triple bonded once and single bonded once, then that carbon is sp carbon. But here is one more rule. If any carbon is connected with 2 time double bond, that time also sp. So for sp we have 2 different scenario. Scenario 1, carbon have 1 time triple bond and carbon has 2 time double bond connectivity. Let's apply this rule here. See, if you see this compound like CH3, C triple bond CH. Okay, now what happens actually? Can you see this carbon is triple bonded? Any carbon is triple bonded, without any hesitation say this is sp carbon. Okay, see this carbon triple bonded, what it is? sp carbon. This concept has one exception also, I will tell you. Okay, see this carbon connected with single bond only. This carbon here single bond and 3 hydrogens in expanded way, like 1 here, 2nd here, 3rd here. So this carbon is involved only with single bond. It means this carbon is sp3 carbon. Okay, see this structure. This structure is known as benzene structure. What I said is, I will tell you the exception of this triple bonded part. So see the exception. See, this carbon is double bonded, yes or no? If this is double bonded carbon, it means this is sp2. Double bonded carbon sp2. Double bonded carbon sp2, sp2. See this carbon. This is triple bonded carbon, yes or no? What I said, triple bonded carbons are sp carbons. But this is the exception, dear student. This compound is known as benzene. And this compound is known as benzene. Okay, so in benzene intermediate, what happens? This triple bonded carbon is not sp, sp2 only. This one also, sp2 only. You can ask this question with your friends. I think they can't answer this. Okay, so then you can feel little bit better because you are knowing bit more. Okay. So in benzene intermediate, what happens? All the carbon atoms are sp2, and the detailed explanation obviously in senior higher classes. So in this way we got some idea about the how to calculate hybridization, but yes, we should take more ideas like this. Suppose if I write CH3 C H double bond C double bond CH2. Okay, tell me about this carbon. This carbon is sp3. Yes or no? Because this carbon connected with single bond only. Now see this carbon. This carbon is double bonded, once double bonded only. So if 1 time double bonded, sp2. If 2 time double bonded, sp. You can see here 2 time double bonded, sp. So this is sp. You must remember this part. Don't forget. Don't get confused between these two. 1 time double bonded sp2, 2 time double bonded sp. Okay, what about this one? This carbon connected with 1 time double bonded. So what it is? It is sp2 only. Okay, so in this way, with this particular technique, like single bonded, double bonded, triple bonded connectivity, you can answer the hybridization questions easily in your competition exam as well as in school also. Let's see few examples of hybridization in organic molecule. See, the very first carbon in the left side, that is sp3 hybridized. Okay. I want to say in this particular picture, I introduced you all the types of hybridization, whether it is sp3, sp2 and sp. Okay. Especially focus on this molecule where carbon is double bonded from both the side and that particular carbon is sp hybridized. Never ever forget that. So, in this way we have completed the calculation part of hybridization. The detailed theory will be discussed in the chemical bonding chapter. Let us see the hybridization in diamond and graphite. You must heard this word diamond and graphite. See dear students, can you see the diamond structure? Okay, in the diamond structure, this carbon, this particular carbon is connected with single bonds only. Can you see that? See, single bond up, single bond left, and that is, see this sign I mean here, if I write, okay, this sign is known as dash, okay, and this particular sign, whether you paint it or you leave it vacant, this particular sign is known as wedge. Okay, there are two names. This dash give the sense of back, rear or behind, and wedge give the sense of front. Okay, let's see now what happens. This diamond, okay, here is a carbon and connected with 4 single bond, 1, 2, 3 and 4. If any carbon is connected with single bond only, what is the hybridization? sp3. That's why in the diamond carbon atom is sp3 hybridized, I mentioned here. Okay, let's talk about the graphite. In graphite, sp2 hybridized. Why? Because the reason is in the graphite what happens, planarity is maintained. Let me tell you one thing, if any carbon atom is sp3 hybridized, sp3, then the shape or structure we should say that is tetrahedral. How tetrahedral looks like? See this tetrahedral, this is tetrahedral, okay. This is what tetrahedral looks like. Tetrahedral is the name of a kind of shape, okay. See, if I say in this way, so what is the name of this shape? This shape name is bent shape, okay. In same way, this shape name is tetrahedral shape, okay. What about sp2? If I say the hybridization is sp2, it means the shape is, geometry is planar. Planar geometry. What is the meaning of planar geometry? See here, see this part, CO3 minus 2, okay, carbonate ion. What happens? Can you see this carbon? This carbon is what? This carbon is double bonded. It means this carbon is sp2 hybridized, okay. But sp2 hybridized they are planar actually. What is the meaning of planar? Planar means all the atoms, whether it is this oxygen or this O minus or this O minus or this carbon, all the atoms are in the same plane. This is the meaning of planar. In tetrahedral, all atoms are not in the same plane. You can see this oxygen, not oxygen, this atom, whatever the atom it is, okay. This atom is in the back side, but this atom is in the front, this atom is in the back, okay. So, the sp2 means planarity actually, okay. sp3 means tetrahedral, okay. One more is there, that is sp. So, sp means linear geometry. What is the meaning of linear? See, what happens, this is a marker, okay. If I write, means if I put 3 drops of water, suppose water is steady and not moving, 1 drop, 2 drop, 3 drop, all that 3 drops of water is in the one straight line, yes or no? So, we will say that these 3 drops of water are linear in one straight line. sp, whenever you find sp hybridization, it means the geometry is linear, okay. So, what is the bond angle? What is the bond angle at this particular area, like this bond angle? What is the bond angle here? So this bond angle is 120 degree. In case of sp2 hybridization, bond angle is 120 degree. Okay, what is the bond angle here? Like this bond angle, how much? Here is 109 degree 28 minute. So I want to say for sp3 the bond angle is BA, bond angle, that is 109 degree approx. We can call it 109 degree 28 minute or only 109 degree, no problem. Planar, whenever it is planar, so the bond angle is 120 degree. When it is linear, the bond angle we should say 180 degree. Linear means what? 180 degree. Okay. So in this way, I gave you the idea of hybridization, then its geometry and bond angle. Let's solve few questions about hybridization topic. See, these are the questions. What you do, you have to find the hybridization of carbon atom. Don't worry about the oxygen or nitrogen or any other atom. Okay, you only calculate the hybridization part of carbon atom and then you match answer from this video, from this lecture. Okay, so now you pause the video, you solve. See how I am solving the very first question, you can check this one, and from the second one you can continue. Okay, see the first question was very easy, so I removed that question. So question number is starting from 2 only. Okay, see this carbon, this is CH3. Okay, so CH3 carbon there, that carbon is involved with single bond only, yes or no? It means that carbon is sp3 hybridized. Okay, and see this carbon is connected with double bond. So this is double bonded carbon, it means this carbon is sp2. Basically what you have to calculate is how many varieties of hybridization in the molecule you have to tell me, and I am talking about carbon only, not nitrogen. See, I am solving the second question, next question also. See this CH3, okay, connected with single bond only. So this is sp3 variety. Okay, and see this carbon connected with triple bond. If any carbon connected with triple bond, it means that that carbon is sp carbon. Okay, so in this way you have to solve the question. So pause the video and solve the question, then match the answer. Okay, the next is, see this carbon is connected with double bond. One double bond connectivity means sp2. So here is only sp2 because only one type of carbon. Okay, see this carbon sp3, this carbon sp3, this carbon sp3, and this carbon sp. So there are only two type of variety, one is sp variety and other remainings are sp3 variety. Okay, so in this way we have calculated, we understood how to find the hybridization of carbon in any carbon molecule. I hope you understood this lecture and you will revise this session because this session is really very important. You will make just proper notes so that it will be very helpful for your school exam and for competition as well. Don't miss this chapter. This chapter is really very important. Thank you.